Okay, so what's more fun than doing one objective? Two objectives. So we're going to do 8.2 and 8.3. It's kind of like saying, let's do another ride at Disneyland. Same. I know what you're saying, but Disneyland can be fun. Can be. Did you go to Disney World? I heard it's very big. Too big for little kids. Living the dream. Okay, we ready? So we're 1 day in a week from your exam, right? So we don't want to let anything slide. If you didn't get 100, get it done in East today. You can see how fast these are. And I don't just throw down the answers for the quizzes, right? We always go through every question. So if you didn't kind of get it, hopefully you do now. And if you still don't kind of get it, you'll ask, right? So now we're going to start talking. Remember I said how we're going to be looking at sine and cos graphs, and we're going to be talking about the A, B, C, and D that I was messing with, stretching it, moving it up, and moving it sideways, and making it taller or thinner, right? Now, the first thing we got to talk about, and there'll be a question like this in your diploma, which one is a periodic function, okay? And you know my exams by now. Like I want to know, do you even know what a periodic function is, right? I'm going to have a definition. So a periodic function is a graph that repeats itself. And you saw that when I graphed the sine function, it just kept doing the same thing over and over and over, and if you just kept it going, it does the same thing. Now, yes, I am recording, I think. Yep. Now, here is kind of some examples below, and then we're going to get more specific about what, this is huge right here. How long is the period? Okay? Now, the first asks, is it periodic? Okay? Now, this is a yes, because it is doing the same thing over and over. Now, a period is, how long does it go before it repeats? So if I go and I go like that, and I stop, is that a period? Okay, there, here. Because if I start again, it's like the same thing again. Okay, it's like every 365 and a quarter days, we start at January 1st again. Okay, so January 1st to December 31st is one period or 1 year. Then we start all over again. Then we start all over again. Okay, if you were counting to 10, I need you to count to 10 1,000 times. What's the period? 10, because then you're going to start at 1 again. 1, 2, 3, 5, 6, 7, 8, 9, 10. Then you're going to go 1, 2, 3, 5, 6, 7, 8, 9, 10. Okay? When you take a certain thing and you keep repeating it, it's called a period. Now let's look at the tide cycle here. Now, when it starts, again, I'm going to use the kind of highlighter here. It starts here. Okay, and at this point right here, do you see how it's going to do it again? Okay, so I guess we should have said yes, this is periodic, and that would be the period. So from here to here would be one period. And if I could take this, let's see if I can. See? Does everybody see this? Do you see how it's repeating? And then how it repeat again? Okay, there's a very good indication that that's the period. I think I drew this thing in two. I could group. Where are you? I never group much. Oh, it doesn't want to do it. Okay. Oh yeah, I think I gotta not worry about it. Okay. Bouncing ball. Periodic? No. Okay. Those feel good when you get them on the diploma. They're like periodic? You're like, no. Okay, or which one isn't periodic, right? Okay. Now, this one for each. Is it periodic? And estimate the period. Is it periodic? Is it repeating something? Well, so if I was to check, because some people are yes, some people are no, so I'm just going to trace it. Where should I stop? Right there. So if it is, okay, so it definitely is periodic. Oh, but it doesn't mean it stopped. It just means that, and it looked like it fell down here, actually. It was just a bad, okay? So that's probably, but draw that in. Pretend that was there. Okay, now, here's the other question, is what would be the period? Okay, so we've kind of established that it's from here to here, right? And it would be nice to know what every little tick is, like 0.05 I think is here. So this one's just mean, actually, because they're not going to be that dumb. Let's, here I got a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's put a 12 here and a 24 here. Cross that out. Okay? Okay, what would you say the period is? See, and the other crappy thing is this should have started at 0 where it's just mean, right? But to be technical, it's actually 11, isn't it? If it would have started at 0, it'd be 12, right? So period's 11, but then the next one looks like it's 12, right? So that's, so maybe this one should have gone like right here or something. This is just a bad question. Badly drawn, right? But we'll say 11 seconds. Just, you guys get the gist, right? Next one. Periodic? No. Next one. Okay, now, this one, it's not much different than that other one, eh? Because it should have started at 0. Oops. Okay, and like they're not that dumb on the diploma. Like, okay, so if I took this and see it falls on there again. So do you see how it happens twice in 0.05 seconds? So how much does it do it? How much is a period then? Should be 0.005 divided by 2, right? Because it happens twice, and that is 0.0025. Okay. So that's 8.2. And I know you'd be absolutely insulted if we stopped right now. You're like, I got up in the morning for that? Okay, so we're going to keep going. Okay. Everyone back here watching, focused? So the next thing now, we're really going to get into talking about the sine graph. So a sinusoidal function is a periodic graph. Now periodic means the same thing keeps repeating, right? Or else it's not periodic. In the form y equals sine x or y equals cos x. Now, like this is huge, right? Y equals sine x. You got to be in radian mode. You might have heard of the radian. Did it all last class, okay? So, will there be students that go to the diploma that do not know how to put their calculator, or will not put their calculator in radian mode? Absolutely, okay? And that's cool. You want that guy competing in the same diploma as you, don't you? Right? We want a lot of those guys, right? The guys that didn't study, the guys that, right? There'll be lots of them, right? We're talking Alberta here, right? There's some people that will, always happens, right? Huge high school, 2,000 people, kid shows up, I haven't seen him all year. He's like, yeah, get right to diploma. You're like, really? Yeah, I'll give it a shot. Why not? Got nothing else to do for a couple hours. Might as well. He's the first guy out, 5%. That was worth it. Yeah. It's not done in a bell curve, but it is, they just have to make sure it has a 65% average all the time. Right? So if you're on the good side of it, it's all good. Okay, and that's what we're aiming for. So we know how to get there, right? We are going to hit mode, hit on first, mode, and we want to make sure radian is blinking and then hit enter. Okay, so mode, you're going to go down to and hit enter. Then we're going to put y equals sine x in. So let's all do that. Right? You don't want your first time. Tan, are you with me here? Okay. So y equals, we're going to put sine x. Now, here's something that I'll show you in a sec to really know things went bad. But let's go to our window now. Now window, the settings are negative 2 pi. So we use our negative 2, and then you hit your pi sign. Now as soon as you hit enter after that, it's going to turn to decimal. Okay? So it just turns it to negative 6.28. And then you put in your 2 pi. And they say use 1, but really pi over 6 is the way that I would always teach it. But you can put 1 there, whatever. And then it says negative 1, 1, 0.5. I like to use negative 2, 2, and you can use 1. So that just gives me more to see on top of the bottom. So then you'll hit graph, and there's your periodic function showing over and over. Now, what I want you to see is if I am in the wrong mode. So if you did that and then you hit graph, okay, it looks like that. And when you are in, so I don't know how much, okay, so I'll just do, because I'm going to put everything in degrees, negative 360, 360, and 30. So what I've done is because I'm in degree mode, I can put degrees in the calculator. But this one especially, so I put degrees in my window settings. Did you see that? If I change this mode to radians, it usually looks like a heartbeat or something. Whoa, lost my whole calculator. Okay. So now you know the two not good scenarios. Okay. If you get the squiggly like crazy, you're in the wrong mode for your window settings. Or it'll be really flat. Okay? So it's good to know when, right? It's not like panic time in a diploma when you get that. It's like, hey, okay, I remember. I got to go hit different mode. Yeah, well, your heart rate would get like that after you just... okay, so we're going to go to negative 2 pi again. And do it right. I'll get out here. Negative 2 pi and 2 pi. So if I'm in radian mode, I'm going to be using radians in my window settings. And what happened with all my ticks? My scale is 30, but 30 was degrees, right? And pi over 6 is the same thing as 30. Do you need to know that? No. Okay? So every one of those little ticks is 30 degrees. So you got 30, 60, 90, 120, 150, 180. Okay? So with that said, let's, if we look down below, it says sketch the graph. And what's really important is to sketch this part. So just kind of go like that. This is 1. This is 0.5. This is negative 0.5. And that's negative 1. This is pi, and this is 2 pi. This is y equals sine x. Now, if you don't know what something looked like originally, and I did a bunch of changes to it, and I said, hey, what did I change? You'd be like, I don't know, I didn't even see what it looked like in the first place. So what's important for you is to know what a Sine X graph looks like, because all we're going to do is mess with that. And if you're like, I don't even know what it's supposed to look like, how am I supposed to tell what you did to it? So the Sine X graph, more specifically, I'm going to change my window to 0, because this is this will be one period of a graph, okay, between 0 and 2 pi. I just changed my y min, or my x min, to 0. So now I'm between 0 and 2 pi. It kind of looks more like this graph. Why do I want you to, do you see how we've made our y max 2? So that's 2 up there. You can see how that's 1, correct? And that is negative 1. So a Sine X graph goes between 1 and negative 1 and 0 and 2 pi. It starts at 0, and after 1, okay, it goes back to the x-axis. So it touches the y-axis, and it starts and finishes here. So you need to know this graph really well, because if I just said to you, okay, so you don't see this. You don't see what I just put in there, okay? And I told you that this is 1, and that's 2. You got to go, okay, that's not a regular sine graph. Why? Because a regular sine graph goes from 1 to negative 1. Now, have I changed the period of it? No. You have to know that. You have to look at that and go, period between 0 and 2 pi. Oh, that's a regular sine graph, 0 and 2 pi. Right? Because if I did this to you, okay, you got to go, okay, that's not a regular sine graph. You've messed with it. You've messed with the period, and you've messed with this is called the amplitude. Okay? So, what's a Sine X graph look like? That. So you always need your bearings, okay? That's called getting back to what you know it should look like. Because on the diploma, they're going to have a different graph drawn. And they're going to say, what is the formula for that graph? And you're going to have everything into place to be able to say it's 2 sine 2x plus 8. Okay? That's what you're going to be able to do. Now, is it a skill you could do if you didn't show up for class? You wouldn't have a chance. You absolutely would not have a chance. But if you just learn all the rules again, just like the logs unit, if you know all the rules, it's really easy stuff. If you don't know your rules, it's, you know, it's pretty well impossible. That's called flipped classroom. You know what? Okay, with x radians, predict the x-intercepts. Okay, now here's what we want to just draw this graph fast. So this is a sine graph. Okay, what is this? 0, this, pi, and this, 2 pi. What is this? -1, and that's 1. So the x ints are 0, pi, and 2 pi. Now, how can I prove that? Well, I'm going to hit my y2, I'm going to make it 0, and I'm going to make it thick so you can see that line come across. What button could I use for right here? How could I find that? So I go second trace 5, enter, enter, enter. I don't have to go up because I'm actually not in stat mode, but see, 3.14, proved it. Okay, and then I'm going to go find the other one, 5, okay. We should be getting 6.28, right? That's 2 pi. And you just have to get it farther than half, so you're a very lazy spider. Oh. Didn't like that very much. What happened? Oh, it came way over there. Why'd you do that? He wasn't very lazy that time. He's like, I'm going way over there. Like, you mock me in front of a bunch of people, I'll show you. Yeah. Yeah, some days he's like, hey, I'm going to over. Okay, and now that's not even there, so I'm going to have to hit my window settings, which really screwed things up. Hopefully it should do it, but yeah, if I put like 4 pi on there, well, that's not really good for learning right now. Okay, but I'd like to see if it'll find it. Maybe because it's right at the edge of the calculator, it won't. Anyone managed to get it without having to go a little bit more than 2 pi? Enter, enter, enter. It's showing both lines. No, it's thinking for a long time. It's not going to give it to me because it's saying I can't see it. Yeah. Okay, so you got to go a little farther to do it. Okay? Now, predict the coordinates of the maximums and the minimums. Now, how I know the max should be 1 and the min -1. Okay, but the actual coordinates are, just so you know, pi over 2. Now what is pi over 2 in degrees? 90. What's this one? 270, which is 3 pi over 2. So the actual maxes and mins is 1, or I should say, pi over 2, comma 1, and 3 pi over 2, comma -1, because that's the x and the y coordinate, right? And this is what we call our min, and this is our max. So it's all about, yeah, you got to memorize this stuff, which I hate. I hate that word. I even like when teachers say, oh, you got to memorize all this, I'd get this sick feeling in my stomach because I'm like, I hate memorizing. But you can get this all on your calculator, right? You just have to graph sine x. You can see it all, right? But it does make life easier if you recognize these things. Now, the first thing we're going to talk about is amplitude. Now, amplitude, okay, now draw a sine graph really fast. This will always be your amplitude, which will be the same thing as this, correct? Now, if you had to define that, where does the amplitude, where is it measured from? Taylor? The max to where? The mid. The middle, or the, this is actually called the midline. Okay? So, amplitude is, by looking visually, it is the max to the midline, or min to the midline, right? Now there is a mathematical way to do it, and that is this formula right here. it's max value on the graph minus min value on the graph divided by 2. Now, in a sine graph, what's the amplitude? How high? 1, isn't it? Okay? Well, because we could just look at it. Like some students are like, why are we going to do this complicated formula? Look, you couldn't see it. Okay? Well, you'll see some later that it will be nice to have this. But let's do its formula. Max. So that's the max value minus the min value. What's the min? -1. So do you see how we're going 1 minus -1? And that's over 2. Now remember, what's 1 minus -1? Okay, 2 negatives become a positive. So that's 1 plus 1, which is 2 divided by 2. The amplitude is 1. Now, it's nice to be able to verify this stuff, and then later you're like, I don't believe that formula. Okay? Hopefully you believe it because we showed it. Now the next thing, what's the period of y equals sine x? What is it? How much to here? Is it pi? 2 pi. So period is 2 pi. So you have to, you're going to memorize this stuff, but hopefully it kind of makes sense. Because like I said, I want to mess with the sine graph, and I want you to go, I know what you messed with. The amplitude's not 1, it's 2. Okay? The period is not 2 pi. You mess with it, right? You've moved the midline, you've moved the whole graph. Okay, so things to remember. This is the amplitude right here. Okay, do you see the amplitude? Now the period can be measured. I actually find you can measure from any two places that are the same. You can go from here to here. You can go peak to peak. You can do from here to here. It's where it's repeated, okay? Now, the next thing we're talking about is the middle, or the midline. Now, the midline is like the average. Whenever I want to find the class average, I add all your marks together and I divide by 36, the total number of people. Okay, so add all your marks together. Actually, I don't do it, the computer does it, but that's what it does. It adds it all up, divides it by 36, gives me the average. Now, if I have two values and I want to find the average, add them together. So it's max plus min divided by 2. So see how we can get mixed up with the amplitude formula already? Because look, this is equation of midline right here. Here, so this is midline. This is equation of amplitude. How are we supposed to not mix those up? Well, I think of midline as middle, average, and we always add for averages, right? This is like average. But let's see how it's different, because what is the midline on what's the y value on a sine graph? The middle. What does y equal? 0, right? Well, let's see how that works. Max plus min, 1 plus min is -1, all divided by 2. What's 1 plus -1 is 0. 0 divided by 2 is 0. Okay? So these are two big formulas that you want to have on your study sheet. And you want to have all the attributes of a sine graph. Period is 2 pi, or 360 degrees. Max, 1. Min, -1. Okay? And where those maxes occur. Now, this one here. What is the amplitude of this graph? Let's do it visually. A. What's the amplitude? 3.5, hey? Is that what it looks like? Okay. Now, let's do it mathematical. What's max? 3.5 minus -3.5 all over 2. So that would be 3.5 plus 3.5, which is 7, divided by 2, which equals 3.5. Okay? Now, These are so easy that sometimes it's almost confusing. Like you're like, why do you have to have a mathematical formula for that? You'll see when I start moving the graph around, the formula does come in handy, but always rely on your visual first. Now, the next thing it asks for the range of the graph. Range is, it's got to be greater or equal to, so we always put the min here and the max on the graph. So y has to be greater or equal to negative 3.5. Remember, we always read from the inside out. And this, y is less than 3.5. So it's always, min max will always be here. Okay, always, 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 I promise you. Okay, so periodic graphs, min, max. Yep. Okay, so the next one. Okay, so this is always, let's just write, this is range. Are you starting to think about what I would ask you tomorrow in a quiz, right? Like, you know what we go through. I'm going to make you accountable for it tomorrow. And that's what, if you can figure out what your, be it professor next year, whatever, is going to ask, and that's why finding their old exams, that's the only true way you're going to find out what they're going to ask, right? That's why I give you those quizzes, so there's no surprises. Guys, this is what I'm going to ask, okay? But even when I'm doing the notes, are you starting to see what we're going to ask? Now, let's look at B. Now, visually, what is the midline? What's the midline? Okay, does this look like the middle of the graph? Yeah. I disagree. The middle of the graph, the same amount should be above that midline as below that midline. That's called the middle, right? Like, if I drew, and I'm like, draw the middle, you guys are like, that? Like, you think that's good? No, well, that explains a couple of things right there, okay? That is not the middle. The middle is always in the middle, okay? So what do you think is the middle of this graph? Okay, so I actually draw it in, and you have to eye it. Like, look back and go, yeah. Okay, that is the same amount above as below. Yeah. If your amplitude's different above and below, you screwed up. That amplitude must be the same. It's always from the midline. You didn't draw the midline if it's different, right? So what is the amplitude? Amp is max minus min over 2, correct? What's max? Minus. What's the min? Now make sure you put in negative 3, and that's all over 2. Now this always has to be in brackets, or you will get it wrong. So what's 1? This is the same thing as going plus 4 over 2, which equals, does that make sense? The amplitude is 2. Now, I want to prove to you that the midline's negative 1, because you guys didn't think it was. Now, I think visually it looks like negative 1, but I still want to prove it. What's the formula? What's the formula? Right? Because mid is the average. So max is 1 plus negative 3 all over 2. What's 1 plus negative 3? Negative 2 over 2. What's negative 2 divided by negative? That's negative 1. Okay? What is the range of this graph? So min goes on the left. Negative 3. Max goes on the right. 1. That's my range. This is either easy or impossible. Okay, there's no middle ground. Okay, now, by looking at this, what's the midline? Okay, so does it look like 2? You can always test. Okay, so we got our midline as 2. What is our amplitude? is 3, correct? Okay, let's prove it. Amp. Ooh. Yeah, it's not 3, is it? No. Okay, so look, here's 2 and there's 4. 2 to 4 is 2. What is each one of those lines? You got to know your scale. They're all going up by 0.5. So what's that? What's this? 0.5. 1. 1.5. Okay? So, hey, this is a good catch. Maybe you said it was 3.5. Okay, so let's find out. Amplitude is supposed to equal max minus min. What's max? 3.5 minus, what's my min? Huh? 0.5 all over 2. 3.5 minus 0.5 is 3 over 2. 3 divided by 2. Okay, now we said midline is 2. And this is what I'm saying. Like I have students in the last test, like, oh, it drives me nuts. They've got their test like on the corner of their desk upside down, and they didn't put their answers in their calculator. They did it all old school, which is good, like it, but they didn't put it in their calculator, so they had the wrong answers, right? And I'm like, why aren't you checking them? Why aren't you putting them in? Like, why have your, and so they get them wrong, right? Which sucks. So this is the same thing. You called amplitude 3.5. You wrote it on your, why don't you come back and use the formula after? Yeah, I know they gave you the picture, but why don't you do it another way? And remember, right, we'll get you 100 on the diploma. Okay? Because we have to try every question more than once, so we're feeling good when we walk out. And trust me, if you're walking out of the diploma before the time ended, I guarantee you weren't trying for 100. Because if you're trying for 100, then you'll do it 3 times. Okay, that should be your goal, to get through that diploma 3 times. And they should be pulling that out of your dead hands before you leave that gym. Right? You know what? I don't know how many times I've taught 30 level courses second semester, but it's often the very last diploma, the very last test you'll ever write. Like, you will not know you graduated 5 minutes early if you walk out. But you could change 2 or 3 things on that test if you stayed 5 minutes more, right? So, you know, be the last person out. Be the last 50 out of that gym, right? Because often what happens is, I've seen it too many times, people leave the gym and they stand outside and wait for their buddies. I'm like, so you weren't, like, what? You weren't even going to go home anyway? You're just going to stand here and wait for your buddies to tell you all the wrong answers they changed and they almost didn't, and then you have to hear about that all the way home, right? Like, I'd be like, I'd go home, cut your losses, because all you're going to do is find out all the things you could have changed, right? Now, midline is such a similar formula. 3.5 plus 0.5 over 2. That gives me 4 over 2, and 4 over 2 is 2. Okay. So, huh?
How can it say that it's that the midline is maximum minus minimum on here?
Where?
I saw it wrong on ours. Okay.
Is it wrong on yours?
Yeah, I'm very confused.
Where?
Is it lighter?
Yeah, it's there a little bit.
Oh, it is there. I didn't see it. I was very confused.
Okay. Is that right here that's wrong?
Yeah.
Okay, so put a plus sign there because yours guys isn't dark enough.
I did not see that.
Yeah, I don't know if your glasses are good enough for that. Okay, now, so we're going to do a visual first. So I always visualize midline. Where is it? Like we're doing B. Where's midline on B? Huh? Okay, now just double check. From here to here is how much? Four. From here to here is? So we got 4 twice. You definitely found the midline. If you got 5 and 3, not the middle. Okay? Do you see how it's 1, 2, 3, 4? Okay? Now, so we found midline and we found amplitude visually, but I still want to do it. So let's do mid. Actually, we'll do amp first because we've always been doing amp is max minus min. Max is 3 minus -5 over 2. Does that make sense? That's 3 plus 5, correct? These two, so that's 8 over 2, which equals 4. Okay, and we got it visually. Now my midline, I'm supposed to get the answer -1. So that's max plus min. Max is 3 plus -5 all over 2. 3 plus -5 is -2 over 2, and that equals -1. So, you know, very, very, very little of this stuff we do this year is intuitive. Okay? But if you learn it, it is pretty easy. Well, I guess that goes for everything, right? But I'm going to force you to learn it, right? That's why we're doing those quizzes every day. Do the study sheet, right? Do the work. Now, midline on this one. Oh no, this one's actually asking just for period. What would you say is the period on this one? Okay, so where does it start? So it starts at 2, the next time it's at 2 again, right? So that should be 1, period, right? And if I took this, do you see how 2, 3, 4, right? So 1 period is how much? Now, this is what you have to find, like, say 90 degrees. You see 90? If that's 90, what must these all be? 30s, right? 30, 60, 90. So you got to find out what your increments are. So you got to go 90 divided by 3, because there's 3 ticks. 1, 2, 3 is 30 degrees. So this is called our increments, right? That's how we can find out what their window settings even are. And you can see, for us, we have to go, because if I bring this back, it is 30, 60, 90, 120. You see that? So the period, we can even put this, is 4 times 30, which equals 120 degrees. Look, there's 90 right here. Do you see where 90 is? How many ticks are in between that? 1, 2, 3. So you don't count the first one. So you know every tick must be 30. So you take 90. So this is the angle divided by number of ticks in between. Okay? Not in between, even counting the 90. So this one here, this one's actually pretty easy. What is on the next one? What would be the period on the next one? Got to go like this. How long does it take for that to happen? What's the period? It's just 3, right? Happens every 3 seconds or whatever that is. Okay, so the next 2 questions are taking in basically everything that we've learned today. So this would be a good kind of question that I could say, hey, do you know all this stuff? So I've got to find the range, the amplitude, the equation of the midline, and the period of the graph. Now, range, what goes first? Min. So this is min, and this is always max, right? So here's number 1. We're doing number 1. What is minimum value? -2. What's maximum value? 3. Okay, does everybody get range? So this question right here, one just like it, would be perfect for me to go, I wonder if they know this stuff, right? Now, on a study sheet, get all this stuff on there, and then you can use it tomorrow. Okay, the next thing is the amplitude. What's the formula for amplitude? Minus min divided by 2. Max is 3 minus negative 2 all over 2. That's the same thing as 3 plus 2, because these negative times a negative is a positive. 3 plus 2 is 5. 5 over 2 is 2.5. I'm going to verify all this stuff by looking later, but we'll... Okay, 3. The equation of the midline. It's max plus min divided by 2. So it's 3 plus negative 2 divided by 2. 3 plus negative 2 is 1 divided by is 1/2, 0.5. Now, do you see where 0.5 is on my... Does that look like the midline? Okay, so first of all, draw it in there. Like, you know how easy it is to make a mathematical error? You guys probably couldn't live long enough to make as many math mistakes as I. Like, I have to do it every day. I miss a negative, or I put a 2 instead of a 3, or whatever, right? It is so easy to make a mistake. So it's good to draw it. And then my amplitude is supposed to be 2.5. Okay, is this 2.5? Okay, like, I'm not going on with this question going, yeah, I think I got it right. Like, I'm going, okay, that makes sense. And the last thing is the period. Now, the period, okay, that's, so maybe we want to see how it starts right down here. Let me just draw it. It starts here, and then it's here again. Oh, I went too far. So I should have went to there. So what are we thinking? Is it 4? I would say it's approximate. So here's the period. And yeah, it's a little past it, right? And it's not at 4.5, so I would say the period is 4.2. And we can just do little like that, about 4.2. Okay, so that's everything we learned in one question. So the rule is, if it was that much fun, you do it again. Okay, so Ms. Johnson's trying to, sitting on an inner tube in the wade pool, West Hampton Mall. The depth of the water below him. I don't know if Mrs. Johnson would be a him. Anyway, in terms of time, during a series of waves can be represented by this. Now it says, what is the depth of the water below Ms. Johnson when no waves are being generated? Okay, so this is basically, I want to say, still water. What would still water be? Of all the things we've learned, what would still water be? Because they're applying it to something we've learned already. Midline, yes. Now by looking at this, what would you say is the midline? 1.6? See, that would be still, see, that's the way it's going up, and then they go back down, right? So if it stopped, it should just be the midline. Okay, so this is the midline. And we got 1.6, but I don't trust myself. I'm going to try it with the formula. That's 2.4. Is it minus 0.8? Plus 0.8. No, it's not negative, look. Divided by 2. I'm not giving his test back. Okay, so what's 2.4 plus... Did you put that top in brackets? Yeah, 3.2 divided by 2. 1.6. Okay. Now, how high is each wave? What do you think they're talking about? The amp. How high? Well, actually, yeah, this is asking for how high is the wave? Now, here's a good question. By looking at it, how high is the wave? 2.4, correct?
Yeah.
Now, what's the amplitude? Max, let's just find it, because this is actually something that you'll need to know how to do. Amplitude is 2.4 minus 0.8 all over 2. And make sure you put that in brackets. That makes sense. 0.8, right? This is, because this is 0.8. Now, yeah, 2.4 minus 0.8 is 1.6. 1.6 divided by 2 is 0.8. Now, can someone find me a way mathematically to find the maximum? Mathematically. Not visually. 2.4 is the answer. Got it. What is a mathematical way to find the amplitude?
The mid plus the min.
No, you're close. It would be the mid plus the amp. Wouldn't that get it for me? Mid plus the amp? Shouldn't that be my max? Okay, and what about min? Mid minus the amp. Okay? Like, I hope it kind of makes sense, too. Like, oh, another formula. I'll memorize it, right? Don't talk to me. I got formulas in here. Okay? So how high was the wave? 2.4, right? And that is the mid plus amp, right? And the mid was 1.6 plus the amplitude was 0.8, which does give you 2.4. And that's like, we've got to be ready for that in the diploma. They will not tell me the max, but they told me the midline and the amplitude. Okay? And again, right, you don't want to be, when you come out of it, like, crap, I couldn't find the max. Like, how do you do that? Remember mid plus amplitude? And you're like, no, are you serious? Yeah. Like, draw it out. It's always been, like, the middle plus the amplitude, that should give you how high it is. And the middle minus the amplitude should be how low it is, right? So we want to be able to see those things. Now, how long does it take for one complete wave to pass? What are they talking about? Period. Okay? Looking here. Okay. I know you guys like watching me color, so I will do that for you. That's one period. When is that? Yeah, let's go with 2.5. Makes sense? Now, what is the approximate depth of the water at 4 seconds? Now, is 4? Or sorry, after 4 seconds. So after 4 seconds. So how am I going to find that? So at 4 seconds, follow it up, and you would get about there, right? So then you just come across to here. One meter. And just put C graph, because later you're going to look at that and go, how did I get that? Okay, all we did was follow 4 up, and then you follow across, right? And if you gave me the formula, do you think we're going to do sinusoidal regression? Yeah. Going to give you a whole bunch of points, and you're going to do that later too. Okay? So we learned lots today, but I think if you got it all on your study sheet, you could do this tomorrow. You obviously want to practice this stuff. So the 8.2 we did was page 201. And 8.3 is page 203 to 207. So again, is this really hard stuff? No. Is it really hard if you weren't here today? Probably suck. Hey, quiz probably wouldn't go well. You'd be like, what's amplitude? Okay. So not just figuring it out, but two minutes left.